All right, folks, listen to number 7. What if the acceleration is not constant? It's not a mystery if you know your calculus, folks. A particle starts from the origin with a velocity at 5 meters per second in the I hat direction at t equals 0. So let me write that down. So a particle starts from the origin at t equals 0 seconds. So that means that at the position here, the vector is just going to be 0 meters plus 0 meters in the I hat direction and in the j hat direction. And the velocity of this particle at that particular second is going to be 5 meters per second in the I hat direction plus 0 meters per second in the j hat direction. So notice I'm just writing the vectors. And moves in the xy plane with a varying acceleration given by the equation a, and a is just going to be always this constant vector that's going to be 0 meters per second square in the I hat direction plus 6 root t. Why is that meters per second square? Okay, that's so there we go. 5 meters per second in the I hat direction is always going to be the velocity. Now the acceleration is pretty straightforward. So let me integrate 6 to the t to the 1/2 power over dt to get what that is. I'm going to just do this to my head, so I kind of forgot my derivative rules, to be honest. You're going to have t to the 1/2 plus a half plus 1, so that's 2 over 2, that's 3 halves, times 6. Eventually you're going to take the derivative to get back to there, so that's going to be, so we're going to flip that. So you're going to have 2/3, so that's going to be cancel. And then minus 1 minus 2 over 2 is going to be a half. So there you go. That's the acceleration. So that's going to be 6 divided by 3 is 2. 2 times 2 is 4. So that we're going to, so this will result into the 4 meters per second to the 5th power t to the 3/2 power in the j hat direction. All right, now we're going to do one more. Now we're going to determine the position of a particle as a function of time. Well, since it starts at the origin, we can simply just say that this is going to be 5 meters per second times the time, because that's ultimately what it's going to be. And that's going to be in the I hat direction. And now we're going to integrate again. We're going to ignore the units. We're going to integrate t to the 3/2 power to respect to t to get the other position. And that's going to be, so that's going to be 4 to the 5 halves times 2/5, I think. T to the 5 halves power. 2 over 2, that should get back. So that's 5 halves. That cancels. So that's going to be 8/5 or 1.6. So that's going to be plus, and plus the initial, well, it doesn't have that. So it's just going to be straight up 1.6 meters per second to the 5th power times t to the 5 halves power in the j hat direction. I think this is the answer. So I believe this is the answer, guys. I think that's all they want. All right, folks. I think the units should match up. So let me double check that. Actually, I'm going to presume that it is correct. I don't see a reason why it wouldn't be. Anyways, folks, that's all.